Swayam Prabha. Digital India. Educated India.
I am Dr. Rajiv Mishra, working as professor in Indian Institute of Technology, Patna. The title of this lecture is Edge Computing Paradigms. So, let us get started to know what do you mean by the edge computing paradigms and the title and the topic of this lecture. So, edge computing is the term used to describe the intelligent computational resources located close to the source of data consumption or the generation. Let me explain it again. This is very important concept. So, edge computing is the term used to describe the intelligent computational resources which are located close to the source of data consumption or the generation. So, it is in contrast to the cloud computing, but it is a new concept. So, we have to now understand this edge computing paradigms to know what do you mean by the edge computing, which describes the intelligent computational resources located close to the source of data consumption or the generation. So, the edge computing has become an important solution to break the bottleneck of emerging technologies by virtue of its advantages of reducing the data transmission, improving the service latency and easing the cloud computing pressure. So, this particular edge computing architecture will become an important complement to the cloud. So, this we have to understand. What do you mean by the complement to the cloud? Even replacing the role of a cloud in some of the scenarios. So, we have to say that this edge, because in earlier lectures we were using the concept of edge cloud computing. Now, we are saying that the edge computing architecture will become the important complement to the cloud. So, it will be mimics the edge computing mimics the services of cloud at local level, whereas it is when you say cloud the has same kind of services, but it is located far ahead in a much bigger form. So, the edge computing is the distributed, makes this cloud truly distributed, and therefore, this edge computing will complement to the cloud. So, there are new applications which requires this kind of support, that is called the edge computing, and therefore, it becomes the complement to the cloud. Whatever cloud was not able to do, or the applications which the cloud was not able to support, now the edge computing is going to serve them, and thereby the new kind of applications which requires which requires latency sensitivity, reducing the data transmission and also easing out the cloud computing pressure. This new application, if they are having these kind of functionalities, then edge computing will be the new addition, and these are the paradigms which we are now discussing. Let us see it again. So, edge computing paradigms is the term used to define or describe the intelligent computational resources which are close to the source of the data consumption or generation. This is an important solution to break the bottleneck of the emerging technologies by virtue of its advantages of reducing the data transmission, improving the service latency and easing the cloud computing resources. Here you can see the distinction which is shown here in this particular slide, that that you have two types of things. One is called intelligent edge. So, when you say intelligent edge, that means you are going to provide the intelligent computation resources. So, here the end devices will get intelligently computational resources either served very close by, located edge nodes, or if it requires more such resources, then it can even depend upon the cloud. So, here in this particular slide you can see there is a line which says that below this line will be an edge layer or edge nodes, and above this there is a cloud. So, different type of clouds, whether it is AWS or Azure, Alibaba cloud, all these are shown over here. So, this is the cloud and this is the edge and this is the end device. So, the edge computing is confined here in the edge and the end. So, this particular way of giving the resources, whether through the close by the computational resource, that is called through the edge, or from the cloud, that is why it is called intelligent computational resources. So, edge computing is the term used to describe the intelligent computational resources, means to say that and located close to the source of the data consumption or the generation, and it is being supported with the help of intelligent edge. Now, other thing is that this particular intelligence, that is AI, how the edge will provide this AI cycle or a pipeline to be implemented in this scenario, that is the edge cloud computing. That means, the AI or the machine learning or an artificial intelligence or the intelligence is now delivered at much faster speed. Therefore, even latency sensitive application will have this leverage of intelligence, and then it is called the edge intelligence. So, intelligent edge or edge intelligence are two important paradigms which this edge computing is going to support and leverage upon. So, let us understand these edge computing paradigm. Now, with proliferation of computing and the storage devices from server clusters in the cloud data center to the personal computers and smartphones, we are now going to become in an information centric era in which the computing is ubiquitous and the computational services are overflowing from cloud to the edge. So, here you can see that this is the cloud and here you are the devices, and these particular cloud was providing the computing and the storage devices with the help of cloud data centers to these kind of personal devices. And now, this particular services are now flowing from cloud to the edge. So, now they are to be provided very close by to the device, not very far from the cloud. So, therefore, why this is happening, why this is a requirement is to support billions of IoT devices. It was not possible to be supported by the cloud. So, with this particular intervention of a cloud computing, it is now possible that billions of IoT devices can be connected to the internet, and there are various companies like Cisco which estimates that such devices will generate the data, that is in the form of zettabytes, and this particular size of the data is also called the big data, which is being generated by the deployment of billion of devices. So, this particular data is generated outside the cloud, and now this particular data which is generated outside the cloud, while the global data center traffic is only small form, that is only in 20.6 zettabytes. So, how this explosion of the data can be handled by the cloud, which is generated outside the cloud. If it is generated outside the cloud, then to support this kind of scalability, it requires the distributed architecture or distributed principles to be applied in the cloud, and therefore, edge computing paradigms are in place. So, this indicates that the data sources for the big data are undergoing transformation from the large scale cloud data center to increasingly wide range of edge devices. However, the existing cloud computing is gradually unable to manage these massively distributed computing power and analyze their particular data. Now, there are two factors. One is called a large number of computation tasks need to be delivered to the cloud for processing, which undoubtedly poses serious challenge on the network capacity and the computing power of the cloud computing infrastructure. Second type, it says that many new type of applications, that is cooperative autonomous driving, have strict tight delay requirement that the cloud would have the difficulty meeting, since it is very far away from the source or from the users. So, the edge computing emerges as an attractive alternative, especially to host the computation task as close as possible to the source and the end users. Certainly, the edge computing and the cloud computing are not mutually exclusive. Instead, the edge complements and extends the cloud to support these kind of new applications, which are delay sensitive application or delay tolerant application, delay sensitive application. So, compared with the cloud computing, only the main advantage of the edge computing combined with the cloud computing are the three folds. The first one is called the backbone network alleviation, that is distributed edge computing nodes can handle a large number of computation tasks without exchanging the corresponding data with the cloud, thus alleviating the traffic load of the network. So, when the traffic need not, if it is served in a distributed manner using the edge computing, then it will alleviate this particular network alleviation, and not much traffic will now require the network bandwidth. Second important thing about the edge computing is that it supports agile service response, that is, the services hosted at the edge can significantly reduce the delay of data transmission and improve the response speed. And third important factor is called powerful cloud backup. So, the cloud can provide powerful processing capabilities and massive storage when the edge cannot afford. So, this are the important alleviation or threefold with the cloud and the edge in comparison. So, as a typical and more widely used new form of application such as deep learning, based intelligent services, and the applications have changed many aspects of the people life due to the great advantage of deep learning in the field of vision, natural language processing. So, these achievements are not only derived from the evolution of deep learning, but also intrinsically or inextricably linked to the increasing data and computing power. So, edge computing paradigms now let us see in a wider range of application scenarios such as smart cities, internet of vehicle, and so on, and there are only a limited number of internet services offered due to the following factor: cost, latency, reliability, and privacy. So, cost means training and inference of these models, that is deep learning models in the cloud, requires devices or the users to transmit massive amount of data to the cloud and thus consuming a large amount of network bandwidth. So, cost is incurring due to this. Latency, the delay to access the cloud services generally is not guaranteed and might not be short enough to satisfy the requirements of many time critical applications such as autonomous driving. Reliability, most of the cloud applications relies on the wireless communication and the backbone network for connecting to the services, but for many industrial scenarios these intelligent services might be highly reliable and even the network connections are lost. Privacy is the most important part. Data sometimes required for deep learning might carry a lot of private information, and the private issues are critical to the areas such as smart home and the cities for safety guarantees. So, with all these factors the edge computing paradigms are yet evolving and supporting these applications with more confidence, and requirements of delay sensitivity is also met. Let us see the cloud computing edge computing paradigms. Intelligent edge can provide a higher service throughput and resource utilization for the edge intelligence. To be specific, edge intelligence is expected to push the deep learning computation from the cloud to the edge as much as possible, thus enabling the distributed low latency and reliable intelligent services. So, deep learning services are deployed close to the requesting users, and the cloud only participate with additional processing is required, hence significantly reducing the latency and the cost of sending the data to the cloud for processing. Since the raw data is required for deep learning services is stored locally on the edge or the user devices themselves instead of the cloud, and protection of user is preserved. Third important thing is that hierarchical computing architecture provides a reliable deep learning computation. Fourth one is with rich data and application scenarios. Edge computing can promote the pervasive application of deep learning and realize the prospects of providing AI for every person and every organization at everywhere, that is through the edge computing. Now, diversified and valuable deep learning services can broaden the commercial value of edge computing and accelerate its deployment and the growth. So, these are some of the advantages of an edge computing, and therefore, let us understand more about that paradigm. On the other hand, intelligent edge aims to incorporate deep learning into the edge for dynamic adaptive maintenance and management. With the deployment of communication technologies, network access methods are becoming more diverse. So, with all that development in place, the edge computing infrastructure acts as the intermediate medium, making the connection more ubiquitous and devices and the cloud more reliable and persistent. Thus, end devices, edge and cloud are gradually merging into a community of the shared resources. However, maintenance and management of such a large and complex overall architecture involving the wireless communication, networking, computing, storage is a major challenge. So, it is not an easy task. So, typical network optimization methodologies rely on the fixed mathematical models. However, it is difficult to accurately model rapidly changing edge network environment. How to do this? So, edge computing has become an important solution to break the bottleneck of emerging technologies by virtue of the advantage of reducing the data transmission, improving the service latency, easing the cloud computing pressure. So, edge computing architecture will become an important complement to the cloud, even replacing the role of cloud in some of the scenarios that we have already told. Now, let us see the cloud edge computing paradigms. So, we look at 6 different type of edge, and these 6 different types can be lumped into 3 different categories: thick, thin and micro. So, here we can see that the edge is divided into 3 different categories, that is thick edge, thin edge, thin edge and micro edge. So, there are 3 types of edge: thick edge, thin edge and micro edge. Now, in this particular category, and then you have a cloud. So, cloud and edge. So, in the edge we are dividing. So, here this is a cloud, and when you say the edge, so it is a thick edge up to this point, then it is a thin edge up to this point, and the micro edge here in this particular case. So, this is about the micro edge and this is the thin edge, and this is the thick edge, and this is the cloud. Now, let us understand that these different type of 6 different type of edge. So, let us see the further classification. So, how the 6 different type of edge is categorized in 3 different categories: thick edge, thin edge and micro edge. So, coming up to the thick edge. So, when we say thick edge, it means that either if it is the cellular tower data center axis, then it is called the thick edge. That means, the edge data centers are called access data centers, or becoming this particular part of the cell tower data centers called thick edge. On premise data centers, if they are built, then it is also called thick edge, or if let us say that computers, network equipments, controllers, computers are there, then it is also thick edge. Thin edge comprises of the network equipments. Network equipments, if it is network equipments or it is a controller, then it is called thick edge. Micro edge comprises of the sensors or the devices if they are being used. So, here this is the micro edge, and then network equipments and the controllers lies over here. This will become the thin edge, and the thick edge is, let us say that rest of the other data centers which are deployed called thick edge. So, the thick edge describes the compute resources typically located within the data center and equipped with the components designated to handle compute intensive tasks such as data storage and analysis. There are 2 types of compute resources located at the thick edge, and which are typically located 100 meters to 40 kilometers from the data source. So, therefore, the thick edge has different type of classification, that is the cell tower data centers, which are the rack based on compute resources located at the base of the cellular tower. Then second one is called on premise data center. So, they are rack based compute resources which are located at the same location as the sensors generating that particular data. So, it is very close by, then it is called thick edge. So, here we can see that if this is the architecture, that is, this is the cloud and this is the thick edge and this is the thin edge and this is the micro edge. So, let us see the distance from source. So, it is 10 plus kilometers, the data source in 10 plus kilometers, that means quite far away. If it is, then it is called the cloud, whereas the thick edge is 1 to 10 kilometers very close by to the source which are generated. Even the network equipment is even less than 1 kilometer, means, and even lesser than that is the sensor or the devices that is on the device itself. So, if you see the latency, if you are doing the computing at the cloud, then the milliseconds, that is 10 plus milliseconds will be there, or 100 milliseconds is required, the round trip time. Similarly, this particular thick edge will take 1/10 of that particular, less than that, and or 1/100th time, or similarly it is even lesser than that delay is there, latency in the thin edge, and if it is done and if it is done on the device, it will be even lesser than that. So, therefore, if we see the thin edge, it describes the intelligent controllers, network equipments and the computers that aggregate the data from the sensors. The thin edge compute resources are typically equipped with the middle tier processors and sometimes AI component, and there are 3 types of compute resources located in the thin edge. So, they are computers, network equipments and controllers. Micro edge describes the intelligent sensors and the devices. Micro edge devices are typically equipped with low power devices, and they are constrained, they are also called constrained devices. They are called sensors and the devices. Now, coming up these three different types of edge architecture which are deployed to realize these different use cases, they are called 100% edge. If let us say that it is not using the cloud, that is on premise data centers you are using, either your computer, network equipment, controller, and so that means either if you are using any of all the edge, but not the cloud, then it is called 100% edge computing. Now, if you are using thick edge plus cloud, here you can see that that you have off prem cloud as well as you have these kind of edge computing. So, large scale on prem SCADA data lakes, they are supplemented by the cloud for extended storage and analytics capabilities called thick edge plus cloud. This is the second type of edge architecture deployments. Third is the thin or the micro edge plus cloud. So, here the cloud will be there, and in the third type is only the thin or thin edge or a micro edge, not the thick edge. This is the third type of configuration which is being allowed. So, small on premise systems, let us say a gateway industrial PCs that forward the data to the cloud for storage and analytics becomes the third different type of edge architecture. So, comparison of these edge architecture, if you can see, so it is 100% edge versus the thick edge plus cloud or a thin edge plus cloud. So, what you can see over here is the maintenance or the downtime reduction, or here in both these cases are shown over here, and so throughput and the process optimization you can also see in this comparison, and labor optimization, reduction control. So, different use cases which are using these kind of downtimes, process optimization, labor optimization, reduction in the control, can choose one of these particular model and they can go along with that process. So, let us see the paradigms of edge computing. So, in the development of edge computing, there have been various new technologies aimed at working at the edge of the network with the same principles, but different focuses such as cloudlet, micro data center, fog computing, and mobile edge computing or multi access edge computing. So, they become different paradigms of edge computing. However, the edge computing community is not reached to any consensus on the standardization of this particular definition, architectures, protocol for the edge computing. Therefore, here we are discussing a common term, edge computing, and this is still an emerging technologies. So, let us see the major paradigms in the edge computing which are often used are as follows. The first paradigm of edge computing is called cloudlet and the micro data centers. Second type of paradigm of an edge computing is the fog computing. Third type of paradigm for the edge computing is called multi-mobile, multi-access edge computing. So, earlier it was a mobile edge computing, mobile edge computing or MEC, which is now changed to multi-access edge computing, but the abbreviation remains the same, MEC. So, multi-access edge computing, and fourth paradigm is called collaborative and edge cloud computing. Let us understand them in great details. So, when we say the first paradigm, that is cloudlets and micro data center, there is a paradigm, this is the paradigm for edge computing. So, let us understand in this particular paradigm which are called as cloudlets and micro data centers. So, cloudlet is a network architecture element that combines mobile computing and the cloud computing. Here you can see that where is the cloudlet. So, cloudlets are lying here near the edge. So, that means below the cloud, these cloudlets will be formed, and this cloudlet is a network architecture element that combines the mobile computing and the cloud computing. Here also you can see the cloudlets. So, it represents the middle layer of 3-tier architecture. So, here we are seeing the 3-tier architecture, and this particular cloudlet forms the middle layer. That is, the mobile devices are micro cloud and the cloud. There are 3 different tier, and its highlights is that it defines the system and create the algorithms that support low latency edge cloud computing, implements the functionality in the open source code as an extension of OpenStack cloud management software. Now, similar to the cloudlet, micro data centers are also designed to complement the cloud. The idea is to package all the computing, storage and network equipment needed to run the customer applications in one enclosure as a standalone secure computing environment for the application that require the low latency or the end devices with limited battery life or the computing capabilities. So, this particular things are shown over here, that we are talking about low latency to the medium latency, and there is a possibility that it will be either the paradigm is cloudlet or the micro data center, and which is nothing but is a network architecture element. Now, coming to the next paradigm, which is called a fog computing. Fog computing assumes the fully distributed multi-tier cloud computing architecture with billions of devices and large scale cloud data centers. So, fog computing is quite popular with Internet of Things like devices which are connected to the cloud, and not everything to be done at the cloud, but before the cloud this particular computing, if it is done, then it is called a fog computing. See this particular scenario here, on one end this is the edge computing, on the other extreme it is a cloud computing, and here the fog computing is the type of small scale computing data center called which are now supporting the billions of the nodes, millions of nodes. So, while the cloud and fog computing paradigms share a similar set of services such as computing, storage and the networking. So, the deployment of fog is targeted to the specific zones on specific areas. So, in addition, fog is designed for applications that require real time response with less latency, such as interactive and IoT applications. Unlike cloudlet, micro data centers and MEC, fog computing is more focused on IoTs. Now, the next paradigm is called multi-access edge computing, called MEC. So, this is a multi-access edge computing and we call it as MEC. So, mobile edge computing places computing capabilities and service environments at the edge of the cellular network. So, here you can see that this particular scenario in this particular figure. So, it is designed to provide the low latency, context and location awareness and higher bandwidth. Deploying the edge servers on the cellular base station allows the user to deploy new applications and services flexibly and quickly. Now, there is a standard which is called European Telecom Standard Institute at Sea further extends the terminology of MEC from mobile edge computing multi-access edge computing by accommodating more wireless technologies such as Wi-Fi. So, here you can see that in any of these 5G services, 4G services, what you can find is radio access network, then very close by to these base stations, cellular base stations, you will find these edge data centers called edge data centers. and they are also called, they will also form to build a mobile edge cloud MEC, or it is also called multi access edge cloud. So, therefore, all the users, let us say the internet users or internet applications, so they require the computation. So, it can happen very close by to the base station, they are called radio access network, supports mobile or multi access edge computing to them, and thereby low latency applications are now possible. So, these standards called European Telecommunication Standard Institute (ETSI) now is also in the support of edge computing. It is using the edge computing support to reduce the latency and to support the latency sensitive application here with the help of multi access edge computing. Let us see the next paradigm, which is called collaborative and edge cloud computing. So, while cloud computing is created for processing computation intensive task, it cannot guarantee the delay requirements throughout the whole process from data generation to the transmission to the execution. Moreover, independent processing on the end or the edge devices is limited by their computing capabilities, power consumption and cost bottleneck. Therefore, collaborative and edge cloud computing is emerging an important trend for computation intensive task. It will be reasonable, segmented and dispatched separately to the end, edge and cloud for the execution, reducing the execution delay of the task while ensuring the accuracy of the results. So, the focus of this collaborative paradigm is not only the successful completion of the task, but also achieving the optimal balance of the energy consumption, server load, transmission and execution delays. So, conclusion, in this lecture we have covered the following concepts. So, what we have given is around the edge intelligence and intelligent edge services at the edge is evolving and is giving the rise of different edge architecture paradigms and also different edge architecture such as thick edge, thin edge and micro edge. Now, different edge computing paradigms we have also seen in this particular lecture, such as cloudlet, micro data centers, fog computing, mobile or multi access edge computing, collaborative and edge cloud computing. So, therefore, what we have seen is that the intelligence computation is making a paradigm shift with the help of edge computing. So, that the intelligence is to be delivered with a low latency and it is to be delivered to everyone and in this way. So, therefore, it is called edge intelligence. Now, on the other hand, the infrastructure, that is edge cloud and the task offloading and different paradigms which is being evolving, such as cloudlet, micro data center, fog computing, multi access edge computing. So, these kind of paradigms are also getting benefited or also being leveraging the artificial intelligence or the intelligence, so that it will provide the intelligent computation resources and thereby these edge computing becomes quite far at par with the cloud computing, but at the lower scale and also at very low latency. So, latency sensitive applications, for that edge computing becomes a complement to the cloud. So, with this we are concluding this particular lecture. Thank you.